All right, so we're going to go over the quiz so that way you can get better prepared for the test. So let's take a look at number 1. Whenever you have a problem that involves multiple logarithms with the same base, condense it to 1. So I am going to rewrite this as ln, and then remember when it's addition, you're supposed to multiply those arguments. So it's 2 times x plus 3. So that's going to give me 2x plus 6 is equal to 3. Then what you need to do is to take the inverse, which is to take this and put it into exponential. So I'm going to go with the base to the power of 3 is equal to the argument. So e to the power of 3 is equal to the argument. From here, I'm solving for x, which means I am subtracting 6 and then dividing by 2. And then I could put that into the calculator, and I end up getting about 7.043. Number 2, for what value of x does the graph of the log function have a vertical asymptote? So to find the vertical asymptote, you're setting the argument equal to 0. So negative 2x equals negative 1, x is equal to positive 1/2. So write the log expression in completely expanded form, applying all the properties. So the fact that we have an exponent, that 2, that's going to go out in front. This is the argument. The fact that the y is in the denominator and the z is in the denominator means it's going to be subtraction. So ln of y minus ln z. And so you will see that that is E. All right, so let's take a look at 4. We're looking for the inverse, which means we switch the x and the y. So when I do this, of course, I'm going to subtract 1. And then the exponent that I'm solving for, or the variable that I'm solving for, is in the exponent. So I have to take the inverse, which means from exponential, I have to take the log. So remember that this is the base. So it's going to write your heart to help you guys out. So it's log base 2. The argument is x minus 1, and it equals y plus 2. So I'm going to subtract 2. And then, of course, we want to, now the 2 could go at the end, but we don't like that because it confuses people if they don't put parentheses around the argument. So we're going to just put that negative 2 out in front. So y equals negative 2 plus log base 2 of x minus 1. All right, so let's just take a look at these properties real quick. So to get rid of a log, we could write it as exponential. So a to the x equals, and then whatever the argument is. So a to the x equals a to the x. And that is true. And the other way to remember that is, remember when you have the base of the logarithm is equal to the base of the argument, where the argument is exponential, these cancel out and you end up getting x equals x. So number 1 is true. Now let's take a look at that same logic of ln. So remember that on an ln, the hidden base is e. And so if I have the base of my log is equal to the base of the argument, where the argument is exponential, remember we get to cross those out just like we did log a, and we said x equals x. So the same argument holds true because there's a hidden base right here. So this ends up being x plus 2 minus, now I'm going to take that 3 and I'm going to bring it over here to the 3x. So I've got log base 3 of 9 and then to the 3x. But what I'm also going to do is rewrite 9 as 3 squared. And then I'm going to apply the power to a power rule, which says that when I've got this, right, power to a power, you multiply. So that means I'm at 6x. And all I did was rewrite that so that these bases, log 3 and then base 3, they cancel. So I'm just going to write it down here. I've got x plus 2 minus, this simplifies to just 6x. And we're checking to see if that equals 2 minus 5x. So I've got x minus 6x is negative 5x plus 2. Does that equal 2 minus 5x? And yes, it does. All right, now we're going to do the same thing idea over here with Roman numeral 3. Remember, if you have multiple logs, you can condense them. So I've got log base 2. I've got a multiplication here because of the addition. So it's log 2a times b, but that 3 is the power. So it's ab cubed, and that equals log base 2 ab cubed. So so Roman numeral 1, 2, and 3 are correct. And then here it says, which of the following values are solutions to this equation? So we did a sample like this. We're going to let u equal e to the x. So really what we have here is 2u squared minus u minus 15 is equal to 0. And what we're going to do is we're going to factor this. So when we factor, what we're going to get is 2u plus 5, and then u minus 3 equals 0. So what we do is we need to solve for u. So u is equal to negative 5 over 2, and u is equal to 3. The answer isn't negative 5 over 2 or 3, but u is. So now what we need to do is go back and replace u with e to the x. And then from here, we need to solve. So remember, when your variable is in the exponent, you want to use the logarithm. So my base is e, so I'm going to take ln. So again, convert it to log form, to take the ln of both sides, and then you get x is equal to ln of negative 5 over 2. We're going to do this over here. We're going to take the ln and ln, so we get x is equal to ln 3. Now remember though, you cannot have a negative argument. So this is no bueno. This Roman numeral 1 is no bueno. It's no solution for that. This is not an interpretation of the argument being negative 5 over 2. So that's an incorrect statement. So we're looking at Roman numeral 3 only. And then now let's take a look at number 7. It says, which of the following log functions could be the graph to the right? So remember though that if I've got a vertical asymptote, that's an x equals negative 3, and I am going to the right. So let's just take a look at each of these arguments. So 3 minus x is equal to 0, which gives me minus 3. This gives me a vertical asymptote at x equals 3. So I know that that's not going to be right, okay? So I'm going to move on to number 2. Number 2 says 2x plus 6, all right? So 2x plus 6, does that equal 0 at when x is negative 3? So let's go 2x equals negative 6, x equals negative 3. So this does have a vertical asymptote at x equals negative 3, but remember, let's take a look at the domain. So not only do we have to make sure the vertical asymptote is right, we have to look at the domain. So I'm going to go 2x plus 6 is greater than 0. So I get 2x is greater than negative 6, x is greater than negative 3, and this domain is x is greater than negative 3. So far 2 is good. Now let's use that same logic for Roman numeral 3. So I've got negative x is equal to 3, x is equal to negative 3. So it also has a vertical asymptote at x equals negative 3. But let's check the domain of this one. Negative x minus 3 is greater than 0. Negative x is greater than 3. Divide by negative 1. Got to flip the sign. This says the domain is less than negative 3, which would indicate a graph on this side, and that's not good. So we have only Roman numeral 2.